Hello and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy, and I'm your host for today, and I've got a special guest that we'll be talking to in a moment, John Stephen. But before we do so, let me encourage you to follow us on LinkedIn if you're not doing so already. And please make sure that if you're following us on a podcast service, give us a 5 star or a thumbs up so other people can find us a little bit better. Well, today we're going to be talking about static application security testing tools, or known as SAST. But first, let's take a moment to hear a word from our sponsor. Don't let unseen vulnerabilities compromise your business. While advances in SaaS, DevOps, and cloud infrastructure have enabled your business to thrive, those advances have also opened new avenues for cybercriminals to exploit. The Chariot Offensive Security Platform keeps your business one step ahead of attackers with comprehensive attack surface management technology and around the clock support from industry leading security engineers. Try it for free at Praetorian.com. Now, you might be thinking, like, hey, G Mark, isn't an in depth discussion on SaaS just a little bit too technical for CISOs? Yeah, CISOs should not be spending their time looking at a SaaS tool to find the vulnerabilities and communicating those vulnerabilities to your dev teams. That's the role of the application security analyst or an information security officer. However, there is one really important thing to understand, and that is, of all the cybersecurity tools you choose to use as a CISO, SAST has the greatest potential to waste developers' time. And so it's really important to get SaaS product selection correct, and having all the developers complaining about cybersecurity tends to be a bad thing. Well, on my show today, we have John Stephen. He is advisory company. You don't run your own business now, but you had been the CTO at Cigital, and you spun off Fortify, and you'd worked at Synopsys where you built Coverity. So you got a lot of background in this area. So I think we've got the right person to give us some insights here. So, John, first of all, welcome to the show.
Thanks. Thanks for having me, G-Mark.
Rather than you just listen to me talk about stuff, because you're really the expert here, let's start at the beginning. What is a SAST tool? When we talk about that, I think a lot of us have sort of an idea, but please tell me what would be your definition of that?
Back in the 90s, we started testing our software for security, and we realized that we wanted to look not just at what we were able to find and test, but every line of code. So the National Institute of Standards and Technology, NIST, created a grant system to do moonshot technology innovation. One of the first things they looked at was static analysis, or instead of testing software in a black box way, building that software like a compiler does and trying to parse all of the code and read it and then analyze whether or not that code was correct or had vulnerabilities. So SAST is a white box analysis, reads the source code and configuration and tries to understand it and find vulnerabilities in that.
So, in a way, if SaaS, if I'm going to run that, I got to have the source code available.
Things have changed over time. When we originally created these technologies in the 90s, they worked, like I said, a lot like compilers for languages like C and C++. They followed the build of the software and built an understanding and internal representation of that software like the tool chain does, and then reasoned over what that tool would do. Now, that was one of the biggest problems in the sort of first generation of SaaS tools, is that configuring it to work inside of your development environments and tool chains was very onerous.
Yeah, it would seem that way. So we had typically, I'm thinking of, we got a SaaS tool and a DAS tool. The dynamic application security testing allows me to just go ahead, plug it in, turn it on, run it, and watch what happens. But SaaS is originally conceived was it more than just sort of a source code analyzer or a lint checker? Was it doing more than that at that point?
I like to think of three classes of static analysis tool. It's kind of like Goldilocks and the Three Bears. The first class is what we call the glorified grep or the linter tools. These are tools that read the source code like strings at face value. And like a regular expression or something similar, they look for dangerous functions or misconfiguration. That's going to work best on infrastructure as code or Kubernetes configuration, things where you set a value like the S3 bucket is encrypted, false, or you call a dangerous function like getS in C. Those linters are the sort of first generation of static analysis. They solve the onerous problem of that build integration, but they don't really understand the code. On the other end of that spectrum, you have technologies like Microsoft's CodeQL or Synopsys's Coverity, which also parse the code and configuration, but they build a detailed internal understanding like the compiler and toolchains do. And then they attempt to reason over the code as a full program and do what's called sound analysis or be able to simulate what would happen when it's run. And they're able to follow the flow of execution, the simulations, and evaluate whether or not an injection happens or an overflow happens or something similar. In the middle, we have the bulk of the commercially available tools like Veracode or Checkmarks. And those tools take a not too hot, not too cold approach in the middle, trying to do just enough simulation that they come up with more findings than a linter because of a greater understanding, but don't require the onerousness of building the full representation and the full program analysis.
Well, since you had some involvement along the way with both Fortify and the Coverity, do we give something up? I mean, there's always a trade when you do something that's a little bit less in terms of the detailed analysis. Is there one better than the other? Is there environments where one approach works better than the other? Or are we just seeing a natural progression and we're now at the latest generation of what makes sense?
There are trade offs with each of those classes, and each of them has a set of defects or defect classes that it's best at finding. And to some extent, we as an industry have sort of glommed all of these into one bucket and thought about it from a one size fits all perspective. So the when we initially did these research grants to invent this tool category set, we were looking at Sun Microsystems servers and CNC plus code. The kinds of vulnerabilities that existed were those overflows, and they required flow analysis. Those tools that we built in that era were designed for those kind of vulnerabilities. That's still very pertinent if you're building driver code, IoT code. There's plenty of applications for those products, and you'll see certain verticals really favor that full program analysis. It's the only way for them to catch really pesky quality or security bugs inside of those large code bases. Linters are also valuable because they do very rapid analysis. They can do analysis in seconds or minutes. And sometimes you have forgotten to set a flag the correct way, or you've made an obviously dangerous call, or you've forgotten a key parameter to a call that's explicit. And so those have their own value. I think the challenge we've had as an industry is we think about all of those classes of product as sort of the same. And we think of analysis of either framework configuration files or JavaScript code the same way we used to think about our server side.
Now, you mentioned CNC. If we take a look at some languages, and as a human, you can go through code and you can intuit perhaps, okay, I have a banana class and it's going to inherit functionality from fruits eat method. Okay, fine. So we got class and method and function. But how much of the SAST tool base is devoted to this type inference versus something other like a flow analysis? Or what's going on here that really works well?
Question is, why are these more complex tools valuable over the linter? And the answer is intrinsic in what you said. So when you look at a code base and you want to do full program analysis and make sure that it's truly free of defects, when you encounter something like a fruit, you have to then go search out in that code base. Well, there's different kinds of fruit in this case. Now, how does that actually work? Imagine you have a web controller and there's different actions associated with that controller. Maybe there's an admin and a user and an enrollment section. The way that the full program analysis tools that are more onerous to use work is they seek out that understanding and they do what's called type inference to detect those relationships between what look like non-related files or classes. And they, using that technology called type inference, they build those connections, build that understanding, and then they use that understanding to reason about how the execution may flow and where it can get. And this allows those tools to find many myriad more instances of problems and then types of problems that are flow based. This is particularly interesting when you have systems built on languages that have a lot of dynamic typing and inheritance and a lot of flow from things that aren't obvious functions. When we look at JavaScript and systems built on Node.js or the Java ecosystem and Spring Boot or .NET and its equivalents, these systems require that level of analysis in order to really search through the code base and uncover the needles in the haystack.
So that type of analysis then, this is not the 10-second, "Oop, you got a compile error or a potential compile error." This is actually trying to look at the code without really running it and saying, the way you set things up, you're going to potentially allow arbitrary execution. You're going to allow all kinds of other bad things. Is there a whole litany of things you can check for? Do you end up throwing the whole wall full of checks at it, or does the person running this tool kind of pre-decide, here's what I'm really concerned about in terms of looking for things?
I want to get to that in a minute, but before
Okay,
I do, let's talk about the three classes and the impact. So, linters run in seconds or minutes.
right.
And this analysis, as you intuit, is going to take considerably longer. Now, these tools have come a long way in a quarter century. Frankly, not only have these tools advanced, but when we were doing this technology in the middle 90s, one of my colleagues wrote down and likes to quote me on the fact that I said, a developer machine would need 16 gigs of RAM to do this kind of analysis. Can you imagine that? There's no way. It was like my Gates moment with the 640K
Yeah,
memory.
640K.
But at the time, I was sitting on a machine with 4 gigs of RAM, and it probably cost 30 grand at the time, right? So machines have come a long way in terms of processing power and memory. So we can do these kind of analyses now more than we could. But this class of tools takes potentially tens of minutes or even hours to run to really follow all of the flow of execution through all of the different paths that are inferred. And if you want to be thorough and sound in your analysis because you're building a controller for a video card that you don't want to be overflowed, that's definitely warranted. If you're building web code and you're building little forms and controllers and you're continuously delivering, you don't have those hours, tens of hours to devote to finding vulnerabilities in that 30 lines of code you checked. So that second class of tools, the check marks and the vericodes and the fortifies of the world, they cheat the soundness of analysis a bit. They make assumptions, they do optimizations that dramatically cut down the amount of time required, but they also impact the accuracy. That means you're not going to find every different class, no false negatives. And that's where the pain has come in terms of that set of trade offs that says we want this thing to run in about 10 minutes so it fits in a build, but we still want some simulation of the execution. And that's where people's pain has come from in terms of adopting this technology stack, in trying to get that bowl of porridge that's just right and trading off the hours it takes to do a correct analysis with accuracy.
If you go back to the mid-90s, and we weren't doing DevOps back then. I think the whole idea of having that fast of a turnaround, I mean, we were happy with waterfall and just clunk, clunk, and at that point, the design of SAST as initially conceived makes perfect sense. You finish your code base on a Friday, you turn on your tool, you go home over the weekend, Monday morning, you come in and see what happened, and you pick up your keyboard and get going. Today, with the requirement to keep pushing code and getting it onto that DevOps, and we try to insert some security into a DevSecOps pipeline, it really then, from what I hear you saying, restricts the soundness of the SAST testing, which means I can't assume that if I've got SAST testing in my DevOps pipeline, that I'm going to produce vulnerability-free code or error-free code. Probably far from it, but yet it has its place, right?
Being in a consulting role for 22 so years, I did a lot of penetration testing. I did a lot of static analysis, tool delivery, and I did a lot of manual code review and a lot of threat modeling. And I kept track of everything that my firm found and that customers accepted as critical or high findings. And what I found was that there was no technique, not dynamic analysis, not static analysis, composition analysis, not threat modeling, that found a majority of findings. There are different classes of findings that different approaches are better at finding. Penetration testing finds a lot of things that it's hard for static analysis to find accurate. You can just throw something at a website and validate that it works or it doesn't work. On the other hand, static analysis can pour through your source code and see that you're storing your passwords with an insecure cipher, something that dynamic testing is going to be very challenged to find. So we need to be cognizant when we're running a security program that we've got 3 to 5, maybe even as many as a dozen defect discovery tools in play in our toolbox. And each of them sort of has a specialty. And we're not going to be able to get a majority of what we expect to find and care about fixing out of any one class of tools.
And I think we're going to talk a little bit in terms of how effective these tools are in actually finding things. But for now, I notice that you're wearing an OWASP jacket. So does OWASP Benchmark have anything to do with our ability to do a better job with SAST?
The OWASP Foundation has done a lot of great work in terms of benchmarking, as well as, frankly, contributing IP and rules to some of these tools. Static analysis tools do pretty poorly on the OWASP benchmark. And so, as a CISO, you can look at that benchmark and say, well, this might not be the most effective tool to incorporate into my defect discovery program. In my own research, which I just referred to, static analysis tools found about 20% of what we ended up delivering overall as critical and high findings the customers accepted. Does that mean it's an ineffective tool? No. In fact, static analysis found that 20% that I report
Mhm.
is more than any other class of tool was able to contribute to those critical and high findings the customers accepted. In fact, DAST only found around 5% of what we ended up reporting over that 20 years. What I would say about the OWASP benchmark is that code is not particularly reflective of enterprise code. And the way that those vulnerabilities, those triggers that they're looking for the tools to find, they're not particularly representative of what's found in the wild. So I would not discount, but I wouldn't worry about those percentages. Again, I think of the 20% that I found and reported over the history as valuable in the context of, again, how is DAST going to find that I've misconfigured something on the back end to store passwords, or here's a piece of code in an admin or a monthly cleanup job that isn't covered in my dynamic testing? What are the things that SAST is going to find that I'm afraid of leaving unfound that I need SAST to target?
So it sounds like SAST in a way is like a seatbelt. It's not going to prevent all injuries from all possible accidents, but it's definitely going to go ahead and reduce and certain situations. So in this particular case, SAST is going to help out, as you said, about 20% of the high and critical vulnerabilities. And another 5 come out of DAS, but it still means there's a lot of work to be done afterwards for humans and things like that. It's part of an effective process that we have. But you had mentioned something a little bit earlier, and you talked about that moonshot early on when you were back there in the 90s and things like that. Can you go back a little bit more and tell me a little bit more about the history of how we got here?
One of my first jobs as a security researcher inside of eventually became Cigital was helping organizations like NASA build code review programs. We all who have been around long enough remember this notion that code used to cost $25,000 a line to put into space. To your point about life cycles and how they've changed towards continuousness, we were moving from waterfall to spiral method. Software had a tremendously heavy and expensive feel to it when you wanted to go high assurance. And so the NIST grants that I referred to early on that were designed to moonshot new technologies focused on that problem of how much it costs to assure a line of code and get it done right. When we built the first static analysis tools back in that time, we never thought of them in the terms that you and I just spoke, where we're going to run them as part of a build, we're going to find automated vulnerabilities, and we're automatically going to find vulnerabilities. We're going to push them to Jira. Instead, we asked ourselves, if you had to do a code review of the NT kernel or a rocket launch module or something like that, how would you navigate a human into that code base? How would you give them cyborg capabilities? The first static analysis tools were about code understanding. They were more close to infrared goggles. Can I put something on my face and see the places I'm supposed to look? Where are the needles in the haystack going to be? And so, from that perspective of code understanding, we built these onerous tools that generated a sound analysis of the code base and gave us experts hints of where to look. But it was always implied that you, as a practitioner, would then figure out if that was a problem for you, if it was exploitable, if there were compensating controls, those other things. We've sort of switched modes here where now we expect the human to be replaced with automation, and we expect to be necessarily a human in that loop of defect discovery and remediation. And so, from one perspective, the technologies that we built and commercialized weren't necessarily designed to do this fully automated approach. They were done so with trade offs that we've really suffered in terms of accuracy.
Between that and what you talked about before, it's almost sounding like you want to go back to Gartner and say, can you break up that story that you put together in one bucket way back when and start treating some of these different approaches differently because you're going to get obviously different results from these approaches. But for those CISOs who are thinking, wait a minute, if I've got SAST and DAST and they're only going to find 25% of my problems, the message isn't that they're bad technology. They're incredibly useful technologies. But I think the real message there is that you have to staff up your people to make sure that you can do beyond just an automated testing. As you had said, this isn't designed to take the human out of the seat and, like in a Dilbert cartoon, all of a sudden there's a little cyborg in there with little lights and bleeping things and that just takes over Wally's job. But rather, this is a tool that helps our developers move forward and can operate sometimes in very fast periods of time. Other times, depending on the complexity of the code base or the development cycle, it might take a little bit longer. But from that perspective, what tips would you offer for people who want to go ahead and understand a little bit more about how to best use these tools?
I would say that there there really are some ways to use it far more effectively than, say, the market has gotten used to using. And two things. One, people are always going to use static analysis for defect discovery, and that's great. Like I said, there are things that it's just much better than other technologies at finding. If you've misconfigured your infrastructure as code, it's going to be great at finding that before you orchestrate and deploy that. If you've misconfigured your web frameworks or your database frameworks and they're storing passwords incorrectly, or you're calling functions incorrectly, it's great at finding those things. So keep track of the things that testing struggles to find and that static analysis is going to easily find. Now, you may have to customize the tool you've chosen to find those things, but that's fine. We'll talk about that more later. The second thing is almost every CISO, especially where the CISO is technology aligned, has what we call a paved road or guardrails or reference security architecture. Because static analysis was designed to understand code, you can use it to evaluate whether or not your developers have stayed on that paved road. What does that mean? Have they called the right functions and controls that you put out there for them in libraries? Or are they encoding things correct? Are they encrypting where they need to? I like to flip the script on people and say, instead of using static analysis as a defect discovery engine to pile up problems, use it to show your developers the paved road and keep them on it.
So that really then is a reinforcer of standards for our developers, where you can catch when they wandered out or they started taking inputs without sanitizing them because they didn't use the libraries that were built to do that, and you could catch that. And so you think over time that it's not just running a tool looking for defects, but in a way, it's helping to educate our developers to a certain level to stop doing things that they shouldn't be doing, at which point we would expect that count to go down and we're going to have much better code. Because usually, if you get good at one thing, you tend to get good at other things in the programming.
Yeah, just real simply, what's the canonical problem in web security that testing is inundated with? Cross site scripting, cross-site request forgery, server-side request forgery. These problems are problems that almost any line of code a developer writes, they can introduce. Testing will find them and will find an avalanche of them. Static analysis can help you use the right dev frameworks that will do the automatic encoding that will prevent those problems, or the automatic token inclusion that will prevent those problems. In other words, apply the controls. So here's a situation: instead of getting on that dynamic hamster wheel of pain with cross-site scripting, cross-site request forgery, using static analysis to make sure that your approved solutions are in place every time the developer builds a new controller, builds a new web app.
Got it. Now, for some CISOs, they may say, we don't use this well, or I'm not sure if we're using it, or they now integrating with a dev shop that looks like there's an opportunity to help them up their game. Are there any steps that you could recommend that you could go through? I don't think you just like buy everything, plug it in, turn it all on, and light up the whole switchboard. It seems like you have to walk before you run here.
So where we've gotten in this conversation is we've built these powerful instruments. We may not be using these instruments in the most satisfying way or in the easiest way for ourselves. What do we do? I would say that those linters that we talked about, that class of tool, we can start simple if you don't have anything in your enterprise with one of the simpler tools, whether it's a simple tool that you're considering or a complex tool that you've had in place for a while. I've found that a lot of executives benefit from disabling a lot of what comes out of the box in that tool. That may seem scary to pay for something and then disable it, but if you turn off a lot of the content that's in the tool, you're aggressively tuning it towards accuracy. And then you can begin to add back these control directives that keep people on the paved road, or you can selectively add back the core content that came out of the box that you feel are the things your developers need to focus on, things that the tool finds well and things that you care about them fixing. So if you start with a simple tool, you disable everything and then turn the volume up a little bit very thoughtfully, then you can afford to integrate these things into a development pipeline in that automated fashion we desire, where the bugs flow into Jira automatically, where developers are required to fix it for release and it becomes gating. And then the tools are going to work as they've been promised to. And we don't have to worry that we disabled a lot out of the box if you purchased a commercial tool, because we can do what we always do as CISOs. We can campaign and incrementally add to what the paved road entails or what our gates demand, and get where we want to be over the realistic 36-month period or whatever your time frame is that's necessary. And that may seem like a very simple situation. Start simple, disable a lot, incrementally add, and then rely on that automation and integration. But that's not how we're driven to buy and adopt these things. So I think it makes a big difference.
Are there any steps that companies tend to miss when they go over to make this thing an effective SaaS program? Is it SaaS that's causing the trouble, or is that really not the issue?
Having done this for 2 decades, I was part of the problem, so maybe this is a reformation. But there's almost a perverse incentive to this whole thing where, if you're gonna compare 2 tools as a buyer, which one do you buy? Well, you bake them off and probably purchase the one that found more, right? Because it's the better tool. Well, more findings in a bake-off probably implies less accuracy when it's deployed to developers and put in place without you there to handhold it. So the process I just described of starting with a simpler tool and disabling things and adding things in a careful way, I think is designed to inoculate that perverse incentive. We as security practitioners who were in the business of defect discovery and assessment probably made worse. Now, the other thing that I think people skip over is that flip from this is a tool that finds defects to this is a tool that helps people stay on the paved road. That verification that people are following the design that your architecture group thoughtfully put out there. Now is the time to do that. You may be listening to this and saying, yeah, but maybe I don't have that maturity. Okay. If you're adopting cloud services from any of the three majors, search for security patterns or security templates or reference architectures. Those cloud providers have produced a mountain of really solid research and documentation of what the paved road should be using their properties and their services. And the static analysis tools that you adopt can be used to find the signatures of your developers either using or the opportunity for them to use those techniques, those patterns, those reference architectures. So, one, through the process I described. Two, think about positive affirmation of developers on the paved road as opposed to defect discovery. And then, of course, incrementally add that great content that's out there now that hasn't been out there historically.
Now, we've been talking about this for about half an hour, and this makes really good sense to me. 'Cause again, you're the expert. I'm actually learning a lot from you, so this is wonderful. But a lot of times, if we're trying to convince senior management that we need to purchase or acquire more tools or implement things differently, we don't have half an hour to get into a deep discussion. So, what are the best reasons we can share with our management team to help them get on board with doing AppSec type initiatives?
That paved road thing, I think, is really valuable. Whether or not you're an organization with a paved road or a secure reference architecture, there's a new executive order out from the Biden administration that says thou shalt threat model. You'll diagram your software, you will look for design defects. We're in a world now where every CISO is going to be responsible for some mechanism inside their organization where they say, we know what secure looks like, and preventatively or proactively, we're keeping our engineers on that path. You can take that sort of the reactive threat modeling approach there, or again, you can use static analysis to make sure that the key functions, libraries, dependencies, services, configuration that you've specified, or that again, your cloud service provider specified, are being used. A lot of CISOs don't have a control that helps them understand where the things they've put out there in the organization are being used in an attaboy way. And so I think that's a key motivator because this allows you to go back to your management and say, well, we have that reference architecture, and look, we're able to show that the impact of that or the adoption of that is increasing. And by the way, we're using our static analysis tools to drive.
Now, are there any mistakes that we might make in trying to come up with this business argument for doing so? And I think you alluded to one a little bit earlier.
Yeah. So one is that sort of reflex we had where when we're trying tools out, the one that finds the most is the one we picked. Then we're shocked it finds too much. The loop I described where we start simple, we turn things off, we add our own content to the tool, and then we integrate it automatically. That gets to the second thing you want to look out for. If static analysis is going to be the value to your organization and your developers that you want it to be, the thing that you really care about is whether or not that tool can run inside of your pipelines, your SCM platforms, and it's going to be a net benefit to the developers. It's going to be self serviceable by those developers or their teams. And so every vendor that has a commercial tool is going to show you all the different integrations they support, from dev tools to change management tools to whatever. But those logo slides don't really show you that it's going to work inside of your GitHub action and your culture for that workflow. So I would say the second thing is make sure that the tools you're selecting are shown to work when you actually connect all that plumbing up inside of your platform team or your developers and make that part of the POC because that's going to be the make or break as to whether or not you can really move that thing through the organization and implement it across the board and whether or not the developers are going to be happy as a benefit to them once you've done it or if it's going to be friction.
And you'd also mentioned a little bit previously about turning off some of the content, building your own and customizing it, which I would imagine would be another way to make it more successful than just trying to as you say, plug it in, turn it on, and light up the whole switchboard, and then inundate your people with stuff. Particularly if you get false positives and things like that. I think that's one of the big ways to drive down confidence in any type of a security tool is the cry wolf problem where you get false positives, and after a while, regardless of your false negative rate, it seems to be what people focus on because we already know that it's not going to catch absolutely everything and things such as that. But from that perspective, even though it's, as we say, 20 some odd percentage correct in terms of finding all this stuff, have you heard any good stories of good wins using this type of a technology? I mean, where does it really pay off?
Yeah, many. So to start off with, I've helped organizations and I've seen organizations that I've measured with building security and maturity model use static analysis in the way I described. They've turned things off and then they've looked to build their own rules inside that tool for helping people stay on the paved road. I've seen organizations campaign their dynamic analysis findings back into static analysis, either by finding the defect earlier or by asking the question of a practitioner, look, this class of defect is really prevalent when we test. And we want to know what static analysis rule we could put in place that shows developers a way to make sure that defect doesn't exist. Again, whether it's to use a control, to obviate it with a secure library, whatever that is. Pushing that question back from the vulnerability management process into the security practitioner community, they can usually come up with something that can then be trialed through 3 or so development teams, proven, and then pushed into the static analysis configuration so that everybody in the organization gets it. And I've seen people effectively, we've mentioned before, campaign out vulnerabilities reacting to their vulnerability management practice with static analysis. That has been highly effective. And where that's paired with training so that the developers have some context and support for those new findings that are going to come out of the development process, that has been a huge home run. That kind of feedback loop has been an obvious win that I've seen organizations. But I've seen wins in other spaces that may be really valuable to this audience as well. One customer who was relatively mature with static analysis as a defect discovery mechanism asked me, if this tool is into understanding code, can we use it to find insider threat? And I said, you know, I'm not sure that you want to use a tool that scans people's code to find insider threat because it's sort of like the wolf watching the hen house. But we quickly wrote some signatures into a static analysis tool looking for things that you'd expect to aid insider threat: trapdoors, logic bombs in the code, Trojans, things that were on a timer and then would pop, things that would disable like a CSRF protection, things that would allow you through to an admin controller without authorization. And we wrote those rules out and we put them in place. And darned if they didn't result in actual prosecution from some insiders. So when you look at static analysis through the lens of this is an instrument that helps me understand my code, the use cases that you can use it for as a CISO multiply. You can use it, like I said, to reinforce and campaign problems in your dynamic testing regimen. You can use it to prove and report to the board how much of your organization is using your reference architecture and driving that initiative through your organization. You can use it to detect suspicious behavior and then follow up on that inside your engineering organization. Those are, in my mind, better uses of the instrument than buy it, roll it out, and bury everybody under an avalanche of potentially inaccurate findings. So if there's one thing that people take home, I hope it's that maybe over the last 20 years we've misused this instrument, and maybe there's a lot of reasons that I can use it differently than it's being sold.
Well, we're almost at the end of our time here. I had a whole bunch of other questions I was going to go through, but I'm going to kind of skip toward the end here because I want to respect our listeners and their time as well. But for recapping, how would you kind of like give us a good summary of everything you could say that you want people to take away with? If they had to kind of skip ahead and listen to this last 2 minutes here. What's the take home here on SAST?
I'd say that SAST is an essential technology to deploy, but like any technology, it's not a silver bullet. It was never intended to compete with dynamic analysis or composition analysis as the only tool you use. It's one that I think organizations can't live without, though. It's kind of like a gas gauge on your car. You use it to inform developers about their just keep them just in time staying on your paved road. You use it to campaign out vulnerabilities. And you do that by customizing this instrument to find and suggest developers the things you want them to focus on. And you can do that incrementally. You can do it one rule at a time or 10 rules at a time, because just like anything else in security, you're never going to boil the ocean by buying a single product. This instrument is designed to be used incrementally and to be used to incrementally incorporate practitioners' knowledge as automation. One thing I'd also like to say is that I think it's time to look at static analysis again, because I think it's about to enter a sort of new renaissance period. We talked earlier about C++ and full program onerous analysis. Right now, we're really invested in technologies like infrastructure as code and Kubernetes. The configurations for these things are very easily parsed, and we're starting to see a whole new crop of static analysis tools that can very rapidly and very accurately scan those kinds of files. So, organizations looking to put the same kind of security instrumentation they have on their application level code to Kubernetes, their Terraform, should really take a look at the static analysis tools that are freely available out there, because it's going to be a big leg up into that space that the testing tools haven't really caught up with.
Makes good sense. John, thank you. This has been awesome. As I say, I've learned probably more on this program than I have on a lot of them. I do a ton of research when I do a monologue, but I always love having an expert come on the show because this has been incredibly valuable. And I think for other CISOs as well and security leaders, this is good high level understanding. We didn't deep dive into the nuances and things like that. So anyway, I'd like to thank John Stephen again for being a guest on our show at CISO Tradecraft. To all the listeners out there, thank you for listening in. Again, if you give us a thumbs up on your favorite podcast platform, we'd appreciate it very much. Until next time, this is G. Mark Hardy, your host. Stay safe out there.